Hello everyone. This is my part 2 of the video for mixed mole practice. This is going to help you with the test questions. I'm going to solve question number 13 with you. It's a two-step process. I hope this video will help you and help you with the understanding of the question. So here we begin. The question says how many atoms? That is our unknown, and they gave us 34 grams. That is what we begin our journey. So 34 grams. Now let's look at the roadmap. Grams is belong. I hope you remember grams belongs to mass. I have also handwritten it in my notes. This is the grams right now over here. So you can see mass is measured in grams. So grams belongs to the mass category. And so here we are. Um, 34 grams, that's where we begin our journey, and the unknown is atoms. As you can look in my notes, I'm going to magnify it again. So atoms belong to particles down here. Atoms, they belong to particles, so particles are right here. So we are going to travel from grams and we will reach particles. Let me minimize it a little bit so you can see the bird eye view of this whole roadmap when I'm talking about it. So it says how many atoms, that is particles, and grams, that is mass. So this is where we begin because it's given. So we are going to follow this roadmap, travel through the lines from mass. We travel down in the middle to moles, and from moles we travel to the right on particles because they are looking for atoms, and atoms are particles. So this is our journey from mass to moles. This is a big divide sign. So mass to moles, I'm going to divide by the molar mass of the whatever molecule they gave us in the question. We will look up on the periodic table to get the molar mass. So the given value 34 will be divided by the molar mass and you will reach moles. And from moles to particles, you will multiply. You see the big multiply sign? All these are multiply signs in my handwriting by Avogadro's number. Some of you were not introduced to the Avogadro's number, but you know the value. Down here, if you look at my handwriting, down here Avogadro's number equals 6.02 times 10 to the power 23. This is our constant. So from moles to particles, you multiply by this constant. Okay, so it's a two-step process: division by molar mass, get to moles, and then the second part is multiply by Avogadro's number and you will get to atoms. Now, how many sulfur atoms are in 34-gram sample of sodium sulfate? So I'm going to first find the molar mass because I don't know my constant. My formula of sodium sulfate, Na2SO4. Down here, I'm calculating the molar mass. So the mass of Na on the periodic table happens to be 23. Right here, 23. Because it's Na2, that means there are two Nas, and I multiply 23 by 2. You don't have to use parentheses in the calculator for multiplication and addition because they complement each other. Calculator does not get confused. It knows when to multiply, when to divide. It knows the priorities. So 23 times 2, that is Na, plus sulfur. Sulfur on the periodic table is 32, and plus oxygen times 4. Because oxygen is 16 and there are 4 oxygens, so we are multiplying 16 and 4. If you put all these values in the calculator, you get 142, which happens to be the molar mass of Na2SO4. So basically, we will be dividing Na34 by 142. Let's do that on the calculator. And I have an online calculator on my computer, so you can see what I'm doing. So 34 divided by 142, and you get 0.239. I'm not going to write all these extended decimal values. I will just use 0.23, and because there is a 9 here, I will round up to 0.24. So I'm going back here. I got my value. It's 0.24 moles. So let's go back to our roadmap. We have traveled one direction from mass to moles. We have done our division and we reached moles. And now the second step is going this way to the particles because we are looking for atoms. Atoms are particles. So from moles to particles, I'm going to multiply 0.024 0.24 moles times Avogadro's number, which is 6.02 times 10 to the power 23. And that's what I'm going to put in the calculator. You can take a look here. I already have this number saved. I will just multiply with 6.02. Hit x to the power y. That's what I'm using for exponent. Sorry, not here, not now, not now. So I'm going to 6.02 times 10 to the power 23. Not number doesn't have a power. The base is 10. And here I get 1.4 and so many other decimal values, e to the power 23. So I'm going to ignore all these decimal values, but I cannot ignore the e. E represents exponent. I cannot ignore the e. So I'm going to copy down 1.44 E23. So my answer is going to be 1.24. Let me check if I remember it correctly. Where is it? 1.44. I'm sorry. 1.4444. And because it's atoms, there are too many atoms. E23. Positive means it's not a negative exponent, and that's my answer. So one more time, roadmap, mass to moles, you go down, and moles to particles, you go this way. First you divide, then you multiply. First time when you divide by molar mass. Second time when you multiply by 6.02 times 10 to the power 23. And we travel from grams to atoms. That's how you travel two-step process. I hope that helped. Good luck with the test. I'm more worried than you are probably. Bye.